Hi students, now we are going to explain the law of conservation of energy, which is very important. Okay. Now what is the statement of this theorem? What is the law of conservation of energy statement? Energy can neither be created nor be destroyed, but one form of energy can be converted into another form. So I have written the statement. So one form of energy only can be converted into another form. So what does it mean? When one energy is lost means it is getting converted into another form of energy. This means that the total energy of a body or the total energy of a given system is always a constant. Okay students, the total energy of a system remains a constant always. So the best example to understand this theorem of a law of conservation of energy is the freely falling body. Now you can see here a ball is taken to a certain height h above the ground surface and it is held at rest at a position A. So A is a point which is at a height h above the ground surface. It is at rest now. I have not yet dropped. I have kept the ball at A. Since it is at rest, its kinetic energy will be equal to 0 and the potential energy will be equal to mgh. So at A, its potential energy is equal to mgh and the kinetic energy is equal to 0 because it is not moving, it is at rest. Therefore, the total energy is equal to potential energy plus kinetic energy. This is equal to mgh plus 0. This is equal to mgh. Have you understood? The total energy of the body at A is equal to mgh. Therefore, the total energy A I will take. Okay. So this is the total energy of the body at the position A. Now I have dropped the ball. In the second picture you can see that the ball is dropped. From A it is moving to a new position B through some distance x. So that before touching the ground it is passing through an intermediate point B. After B it will come down. Again the height will decrease continuously. Finally it is going to touch the ground at some time. So in between when it crosses a point B, it is at what distance from A? It is at a distance of x. Okay students? So now when it crosses the point B, let its velocity be denoted by Vp. So the velocity at A is 0. As it is dropped, the velocity continuously increases because its acceleration is equal to g, which is equal to the acceleration due to gravity. So at the point B, when it touches or crosses, its velocity is taken to be the symbol Vp. Okay students? So the initial velocity at A is equal to 0 and the final velocity at B is equal to Vb. So the equations of motion I am using now, this Vb square is equal to u square plus 2a into the distance moved is equal to x. So this is equal to 0 plus 2a into x. Therefore, what is the kinetic energy of the body at B is equal to half into m into Vb square. So this is equal to half into m into, instead of Vb square I have to write 2ax, which is nothing but 2gx. I can write this a is nothing but the acceleration due to gravity g. So instead of this 2ax I can substitute 2g into x. This 2 and 2 get cancelled. The remaining will be equal to what? mg into x. Okay. So what is the kinetic energy of the body at B is equal to mgx. Now B is at what height above the ground surface now? Since the height is lowered by x, the position or height of B above the surface of the earth is now equal to h minus x. Therefore, its potential energy at B must be equal to mg into h minus x. So this is equal to mgh minus mgx. Therefore, the total energy at B is equal to this kinetic energy plus potential energy. So kinetic energy is mgx. So this is equal to mgx plus potential energy is mgh minus mgx. So this is mgh minus mgx. So this mgx and minus mgx get cancelled. Therefore, the total energy at B is equal to what? mgh. At position A also it is mgh. At B also we have shown that the total energy is equal to what? mgh only. Okay. Now coming to the third one. Okay, the third position. Now the ball has touched the ground surface with a maximum velocity which is equal to what? Vc. So when a ball is dropped continuously, its velocity is increasing due to acceleration due to gravity. And finally when it strikes against the ground, the moment it strikes, its velocity will be maximum, and that highest velocity or maximum velocity is taking the symbol Vc. C is the lowermost point on the ground surface. So now here in this case the potential energy is equal to 0 because the ball is on the surface of the earth. Since height is equal to 0, the potential energy of the body at this C is equal to 0. So potential energy at C is equal to 0, and kinetic energy is at C is equal to half into m into Vc square. Okay. Now we get an expression for Vc square. Vc square is equal to U square plus 2 into G into S. Okay, 2 into G into H. So in this case it has traveled a distance equal to the height h itself. So how much distance it has traveled from A to C is equal to the height h itself. So it is equal to what? 2gh. And what is the initial velocity at the highest point? It is equal to 0. Therefore this is equal to what? 0 plus 2g into h. Therefore what is kinetic energy at the point C must be equal to half into m into Vc square. So this is equal to half into m into 2gx. So this 2 and 2 get cancelled. The remaining factor is equal to what? mgh. So the potential energy is equal to 0 and the kinetic energy is equal to mgh. Therefore the total energy at C is equal to this is 0 plus mgh. Therefore the total energy at C is also equal to mg into h. So now you look at the three positions of the ball. When the ball was initially at A, its total energy at A was equal to mgh. And when the ball is crossing the point B in between the highest and the lowest point, it is having a total energy given by EB is equal to mgh. And when it strikes the ground at the point C, which is the lowermost point, now also it is having the same total energy EC is equal to what? mgh. So we have proved that the total energy of the body remains constant at all points. Okay students, have you understood? So once again I am telling you the statement of law of conservation of energy. Okay, it states that energy can neither be created nor be destroyed, but one form of energy can be converted into another form of energy, which means that the total energy of a body or the total energy of a system remains constant always. Okay, fine.